So today's lesson is on polynomial division, and we can do this by using what's called long division or synthetic division. As you'll see soon, any of the polynomials can be divided using long division, but only certain polynomials can be divided using synthetic division. So we are going to start with a problem that would be something you learned from a few years ago. So without a calculator, if I asked you to divide 6,496 by 17, then you would need to think about using long division. And so it would look like this. And we would want to say, okay, well, can 17 go into 6? Well, no, it can't. So can 17 go into 64? So yes, it can, 3 times. 3 times 17 would be 51. And so we've multiplied the 3 times the 17, gotten the 51, and now we're going to subtract. And so 64 minus 51 is 13. We're going to bring down the 9. And then we're going to repeat that process, and we're going to follow the steps repeating that process. We would get something like this. So when we divide, we get 382 with a remainder of 2. So dividing 6,496 by 17 is 382 with a remainder of 2. We're not going to worry about trying to do 382 point something and continue it with a decimal value. We're just going to be focused on the remainder because that's what we're going to be using when we start dividing these polynomials. So just as kind of a thought here, division is the opposite of multiplication. So if we take our quotient, which is what we had right here, 382, and we multiply that by the divisor, which is 17, so we're multiplying both of those, and then adding the remainder, that should give us this dividend. Okay. So let's look at a problem where we're going to use long division but with polynomials. So to do this, we're going to take 2x squared plus 1, and underneath our divide sign, we're going to put this polynomial, 6x cubed plus 10x squared plus x plus 8. Now, this problem doesn't come up, but on some problems what we're going to want to pay attention to are all the degrees of each of the terms within this first polynomial. To start with here, we've got a cubic term with a degree of 3. We want to make sure that starting with that 3 that we have all the terms down to the term that has a degree of 0. So we've got the degree of 3, degree of 2, degree of 1, and degree of 0. If we were missing one of those, then we would need to put that in later. And we'll talk about that later. So from here, in order to use our long division, we're going to ask ourselves, okay, what am I going to get if I divide the 6x cubed by the first term of our divisor, 2x squared? So if I divide 6x cubed by 2x squared, I get 3x. And so I'm going to write that 3x right above the other linear term, which is that x. That just keeps things organized a little bit for me. Then I'm going to multiply 3x times 2x squared is 6x cubed. So we always want these two things to be the same. And then I'm also going to multiply 3x times my other term in the binomial here of 1. So 3x times 1 gives me a positive 3x. Now, following our long division steps, we're going to subtract. I'm going to subtract all of my terms, so I'm going to just change each of those. This first term cancels out to be 0, so we're not going to worry about that. We need to bring down this 10x squared, and then here we've got x minus 3x, so we've got a minus 2x, and we can also bring down this plus 8. From here, we're going to repeat this process. We're going to ask ourselves, what's 10x squared divided by 2x squared? And that would give me a 5. And so if I take 5 times 2x squared, that gives me 10x squared. And 5 times 1 gives me a positive 5. Once again, I subtract. So I subtract this term, I subtract the 5, and those cancel, leaving me with negative 2x plus 3. Now if I try and divide negative 2x by 2x squared, this x squared is not going to go into that x. So that's as far as I can take this problem in terms of dividing. And so what this looks like is 3x plus 5 with a remainder. And so the way I'm going to write this remainder is I'm going to add the remainder. In this case, it's the negative 2x plus 3. But since that remainder really is being divided by what we started with, 2x squared plus 1, we need to show that division still and write that our remainder of negative 2x plus 3 is being divided by 2x squared plus 1. So that is our answer. If I were to take this answer and multiply it by 2x squared plus 1, I would get our dividend here of 6x cubed plus 10x squared plus x plus 8. Alright, so we're going to try another one here. This one is missing some terms in our first polynomial. So when I write x to the fifth minus 2x to the fourth, I notice there's no cubic term there. And so what I'm going to do is I'm going to add a 0 x cubed in. Then I've got plus 7x squared. I'm missing my linear term, so I'm going to put a plus 0x there, and then I have the minus 5. That is being divided by x squared minus 3. So repeating the process from our last problem, we're taking x to the fifth and we're dividing it by x squared, which gives us x cubed. We multiply x cubed times x squared, which gives us x to the fifth. X cubed times negative 3 gives us negative 3x cubed. I'm writing that right under the same like terms. I subtract both of these. I'm going to subtract the x to the fifth. Since I'm subtracting a negative 3x cubed, that really turns into an addition there. And so I bring down the negative 2x to the fourth, and I have plus 3x cubed. I'll also bring down this plus 7x squared. So now negative 2x to the fourth divided by x squared would give me negative 2x squared. Notice that it's written right above our other quadratic term. And so now if I multiply, I get negative 2x to the fourth, and negative 2x squared times negative 3 would be a positive 6x squared. I subtract both of these, changing the sign, so this turns into a plus. Here we're going to have a minus, and we have 3x cubed plus 1x squared, and I'll bring down the plus 0x. Once again, divide 3x cubed by x squared, and we get a positive 3x. 3x times x squared is 3x cubed. 3x times negative 3 is negative 9x. I subtract, changing the signs, and I have x squared plus 9x minus 5. One more time, divide. X squared goes into x squared one time, so I have a plus 1 up here on the top. 1 times x squared is x squared. 1 times negative 3, negative 3. Subtract one more time. Bring down the 9x. Negative 5 plus 3 is negative 2. And so our answer is x cubed minus 2x squared plus 3x plus 1 plus my remainder 9x minus 2 divided by x squared minus 3. Alright, so that is long division. Now we're going to look at synthetic division. So in order to use synthetic division, we have to be dividing by a polynomial of degree 1 with a leading coefficient of just 1. The constant term can be any value, but it has to be in that form where we have a polynomial with a leading coefficient of 1 and a degree of 1. If it doesn't have that, we can't use synthetic division. So the way that we're going to do this is we're going to only really worry about the coefficients of our polynomial here. So I'm going to have a 3. This coefficient right here would be a negative 1. Then I'd have a 2. Notice there's no linear term. There's no term with just x. So I'm going to put a 0 in that place and then put my negative 10. After that, I'm going to focus not on the variable x, but on the 3 here, and I'm actually going to change the sign to a negative 3. What that's going to allow me to do is, instead of subtracting as I go along here, I'm going to be able to add. So here's how synthetic division works. We're going to first bring down our first value here of 3 below the line, and then I'm going to multiply that 3 by this negative 3 outside. And so negative 3 times 3 gives me a negative 9. I'm going to write that above the line in the next column over. These two numbers that are above the line are going to be added together, and that sum is negative 10. And then I repeat this process of multiplying the value under the line by the negative 3. So negative 3 times negative 10 is 30. I add and get 32. I multiply again. Negative 3 times 32 is negative 96. Add and get negative 96. Negative 3 times negative 96 is positive 288, and then when I add I get 278. And these numbers that are below the line are now basically the coefficients for each of my terms. Since not only I'm dividing by this 3, I'm also dividing by an x here, I have to think about, well, if I'm dividing each of these terms by x, that's going to decrease the degree of each of those terms by 1. And so what I'm going to get here is I'm going to have this leading coefficient of 3, but instead of being 3x to the 4th, that power gets decreased by 1 and it's 3x cubed. And then from there, we just decrease the degree in each of the following terms. So minus 10x squared plus 32x minus 96, and you guess that that 278 would therefore be our remainder. So we have plus 278 divided by what our divisor was of x plus 3. So you can see it's, if nothing else, a kind of shorter method and probably a little bit faster as well. I want to show you on this next example kind of a problem where we could do it long division, synthetic division, and hopefully you can see kind of where the numbers are coming from in the synthetic division based on how we've done the problem using long division. So if I take x minus 3 and I'm dividing 2x cubed minus x squared plus 0x plus 3 by that x minus 3 using long division, I would have a 2x squared here, so 2x squared times x is 2x cubed, and 2x squared times negative 3 is negative 6x squared. I subtract and get 5x squared plus 0x. What do I need? I need a 5x. 5x times x is 5x squared. 5x times negative 3 is negative 15x. Change the signs. 15x plus 3 when we bring the 3 down. And I would then need to multiply by 15. 15 times x, 15x. 15 times negative 3 is negative 45. And when I change the signs, when I subtract, I get a remainder of 48. Now if I apply the same idea to synthetic division, I'm going to have a positive 3 here, and then the coefficients that I'm going to use are 2, negative 1, 0, and 3. And you notice that these coefficients are the same as the coefficients right across here. If I bring down the 2, I start with that. Then I multiply 3 times 2, which gives me 6. From there we add and get 5. Multiply, there's a 15. Also a 15 below the line since we're adding 0 and 15. 3 times 15 is 45. And then we have our 48. And so hopefully you see kind of the connection here, and I'll kind of highlight these values. So here's our coefficient of 6. Above the line we have a 6. Next step down, we've got a 15x, our coefficient here, 15. Going one step further here, here's our 45. Above the line we've got 45. Then if we're talking below the line values, we've got our 2x squared. We've got our 5x, so here's our 2, here's our 5, here's our 15, and here's our 48.